All right, guys, let's work our way through a few problems on the 10.3 worksheet. So in this one here, we're supposed to find the area of each regular polygon, and they do want our answers expressed in simplest form, not as decimals. So because we're dealing with regular polygons, we've got a formula for this. So using our three-step process, we always begin with that formula. Area of a regular polygon is equal to 1/2 times the perimeter of that polygon multiplied by little a, which is our apothem. Step 2, fill in what you know. So the area here is equal to 1/2. Right now we don't know the perimeter, nor do we know the apothem, so we've got two things that we've got to find. Let's get working on perimeter first. Now what they did tell us here is that one side of this triangle has a length of 36. And because it is a regular polygon, we know that all three sides of this figure are congruent. That's a 36 as well, and that's a 36 as well. Now, it drives me nuts to hear smart people at this level now grab their calculator and type in 36 plus 36 plus 36. To do this in a better way, to find perimeter, you take the length of each side, which we know is 36, and you multiply that by the number of sides, which in this case is 3. So 36 times 3 tells us that our perimeter here is going to equal 108. So we now know that our perimeter is a 108, and we'll go ahead and write that in there. What we have to worry about next, though, is figuring out A, the length of the apothem. So hopefully you watched the video on this. To find an apothem, everybody, you take a point at the center, or the center of that figure, and you drop an altitude. That doesn't look very good, sorry. Something like that. And you drop an altitude then perpendicular to one side. And what you do then at the same time is it bisects that side of the polygon. So if the whole triangle had a side length of 36, this piece right here is going to have a length of 18. That little piece that you drew there is A, that's your apothem, and this piece here in red, which went from the center to one of the vertices of the polygon, that's R. That's what we call your radius. Now, if you saw this in the video, great. If not, here's how we figure this out. We need to know what kind of triangle that is. So the way we do it is we need to find the measure of a central angle, which we call theta. That is always going to be 360 degrees divided by the number of sides you're dealing with in your polygon. This is a triangle, so it's 3 sides. And 360 divided by 3 is going to be 120. Now what we really just did there, guys, is we found the measure of this angle right here in green to be 120 degrees. But what we need is this angle right here. And the apothem bisected that 120 degree angle. So what we're now going to do is take 120 degrees, divide it by 2, and that's going to tell us that this angle right here, didn't leave myself much room there. That's not what I wanted to do. Anyway, that this angle right there, everybody, is 60 degrees. That means that we're dealing with a 30, 60, 90 right triangle. And in that 30, 60, 90, we know the length of our long leg is 18. We need to come up with the length of our short leg. So if you need to go back to your notes or the video from section 8.2, go ahead and do that. But to go from a long leg to a short leg in a 30, 60, 90, we are going to take that long leg, which is 18, and divide it by the square root of 3. Now, if you have one of the newer TI calculators, you can just type that in and it'll give you the answer. But for most of us, we're going to have to rationalize the denominator. We multiply this number by the ugly denominator, root 3, over itself. Okay, so in the numerator, 18 multiplied by the square root of 3 is just 18 root 3. And in the denominator, root 3 times root 3 is 3. And now we have two rational numbers here of 18 and 3 that can be divided out. 18 divided by 3 is 6, and then the root 3 just tags along there. So now we know that our apothem here is 6 times the square root of 3. And now from there, everybody, we know P, we know A, so we're ready to go ahead and type this in to our calculator here. So area is equal to, now do notice, they did not want the answer as a decimal. They want it in simplest form. So that root 3 is going to be a bit of a problem. But actually, this is much easier. All we do is we multiply the 1/2 times the 108 and then times just the 6 in our calculators. So let me do that with you here, guys. Let's clear everything out that we have right there. Okay, and for 1/2, I'm just going to do a 0.5 multiplied by our perimeter of 108 times the 6 from the apothem, and we end up with 324. So we write 324, and then that root 3 at the end almost acts kind of like a variable, like an x. It just tags along there. So 324 root 3, no units were given to us, so we're going to write square units then for that answer. Okay, so that's how we handled number 1. That was a regular triangle in which we were given a side length. So 2 things are going to change now in number 5. We're now given a regular hexagon, a 6-sided figure where they're all congruent. And what they gave us here, the 6 root 3, was the length of our apothem. So that is going to be A equals, and that's the 6 root 3 right there. Okay. So step 1, write down what we know. Area of a regular polygon, our formula here, is 1/2 times perimeter times apothem. That works because the directions told me this was a regular polygon. Step 2, fill in what we know. Area is equal to, we have a 1/2. The perimeter, we do not know right now, but the apothem they were nice enough to give us is 6 root 3. But we've got to work on finding P. And to do that, everybody, I'm going to go ahead and do 2 things that I almost always do. I always draw the radius if it's not, or excuse me, the apothem if it's not there. Well, it is. But then I'm also going to draw the radius that goes right next to it, and that's going to be R. Now, along with that, I also like to highlight this little piece right over here. Okay, and that little chunk, for no good reason, I always call that X. That is eventually going to lead us to our perimeter. So let's talk about how that works. But before we do that, just like in the last problem, we've got to figure out the measure of theta, which is the measure of our central angle. So we always start with 360 degrees, and we divide that by the total number of sides, which in a hexagon is 6. And 360 divided by 6 means that each central angle here is 60 degrees. But our apothem bisects that 60-degree central angle. So we're now going to take that 60 and divide it by 2 and get 30 degrees for the measure of this angle right here between our apothem and our radius. Well, if you take a look at that triangle, you see a right angle at 90. We just came up with a 30. That means that we have another 30, 60, 90 right triangle. And again here, we know the length of our long leg. We now want to come up with the length of our short leg. So to do that, we find X, the short leg, by taking the long leg, 6 root 3, and dividing it by the square root of 3. Well, this actually works out easier than the problem we just did. We have an identical factor of root 3 in both the top and the bottom, so they just cancel each other out, and we end up with X is equal to 6. Now, how does that help us? X is half the length of one side. So if we want to come up with S over here, which is the length of an entire side, we simply take X, which is 6 in this case, and we double it. Multiply that by 2 to get 12 for the length of each side. So each side in this hexagon has a length of 12. We're looking for perimeter though, and to find perimeter, we're going to take the length of each side, which is 12, and multiply it by the number of sides, which is 6, and that's going to get us 72 for the perimeter of this figure, so we'll go ahead and write that in there. All right, that took some work, everybody, but we now know everything we need, so now we're ready to type this into our calculator. And again, we can leave out the root 3 for now and just type in 1/2 times 72 times 6. So a 0.5 times a 72 times 6 is going to get us 216. So our area is 216, and the root 3 just tags along for the ride. We just put a generic square units on that, and there's our answer for problem number 5. Okay. Keeps getting tougher. And now, maybe even more so. So 2 new things on number 7. First of all, we're dealing with a square for the first time. And second of all, the piece of information that they gave us, everybody, is the radius here. That was already drawn for us. So this is something I would have you draw if it wasn't already there. So there's your radius. And the apothem then, I'm going to draw this one to the right, comes right over here. So that's A. We know that this is a right angle. And what we also created right there was this little piece right here, and we always call that x. Okay, what kind of triangle did we just form? Well, to figure that out, we've got to find the measure of our central angle. Theta is always 360 degrees divided by the total number of sides here, which is 4. So theta is going to end up being 90 degrees. And then we always cut that theta in half. 90 divided by 2 is going to be 45 degrees. So this angle right here is 45. And that means here that we're dealing with a 45, 45, 90 right triangle, and that's going to help us figure out what we need. I got a little ahead of myself, guys. I should have gone with my 3-step process here, starting with the formula. Area of a regular polygon is equal to 1/2 times perimeter times apothem. Step 2, area is equal to 1/2. Well, at this point, we do not know the perimeter, nor do we know the length of the apothem, and that's probably now when I should have come over here and started doing this work. Anyway, now that we're there, well, what we found before is still correct. We know that's a 45, 45, 90 triangle, and within that 45, 45, 90, it's the hypotenuse, 12 root 2, that was given to us. We've got to come up with A, which is one of the legs. So to find a leg in a 45, 45, 90, you take your hypotenuse, which is 12 root 2, and divide it by the square root of 2. Well, once again, the root 2's cancel each other out, and we find that our apothem here is just equal to 12. So we needed that for the formula. The apothem is 12. Now, let's work on finding the length of x right over here. Well, we caught a little break here. In a 45, 45, 90 triangle, we know that triangle is isosceles. So the two legs have to be congruent. So if A is 12, guess what? X has to be exactly the same thing. X is going to be 12 as well. Now, S is the length of an entire side here, which is always going to be twice as big as x. So for a side length, we're going to take that 12, multiply it by 2, and get 24 for the length of each side. And lastly, to come up with capital P, the perimeter now of the entire square, we take the length of each side, which is 24, we multiply that by 4, because we have 4 sides here, and that gets us 96 for the perimeter of that entire figure. So we had to do a lot of heavy lifting on that one. We had to come up with both the perimeter and the apothem on our own, but eventually we have it. So now it's time to go to the calculator, and you'll notice with this one, there are no irrational numbers. There are no square roots here. Everything is a nice rational number, so we can type all of it into the calculator at once. 1/2 times 96 times 12. And that's going to get us our answer here, everybody, of 576 square units for the area of this square here in problem number 7. All right, guys, 10-3 is a tough section. Keep plugging away. If you have any questions, please let me know.